These chargers range from rupees 150 to rupees 2500. Some are original, some are off-brand. Today, I am not going to judge them by the logo or the price. I am going to let the instruments decide. Which one has the cleanest power? Which one overheats? Which one holds out 5 volts under load? By the end of this video, we will know. So meet our contestants. This is a rupees 150 off-brand level charger. This is also an off-brand charger. It costs about rupees 300. This is a 3-port USB charger. It costs about rupees 450. And this is an original ASUS charger. This is also an aftermarket charger. It is marketed as a 25 watt USB PD charger. And it costs about rupees 500. This is an original Samsung charger. It is a 15 watt original Samsung charger. This is a 33 watt original Motorola charger. It costs about rupees 1300. This is a 68 watt original Motorola charger. It costs about rupees 1700 in the market. And this is a 125 watt original Motorola charger. It costs about rupees 2400 in the market, but it is not easily available in India. We will be testing only the 5 volts output of all even the PD chargers. This is to make them compete with the non-PD chargers. And we will load up the output with these two parallel resistors. These are 4.7 ohms resistors, which when paralleled should draw about 2 to 2.5 amperes from these chargers at 5 volts. And this is a USB detector. It will show us the output current and the output voltage. This will also help us determine how much the output voltage drops under load. This is the most important part of our puzzle. This is our oscilloscope. This will give us the quality metric of a phone charger. A phone charger is supposed to supply a smooth 5 volts, like calm water flowing through a pipe. But no charger is perfect. Some chargers produce tiny waves on top of that 5 volts. These tiny waves are called ripple voltage. A good charger has very small ripples, while a poor quality charger can have larger ones. Your phone has to work harder to filter out these ripples. And over long periods, excessive ripple means more heat, more stress on the phone's power circuitry, and generally poor power quality. So let us bring our first contestant. Our 125 watt charger, the most expensive of the lot. This is the 125 watt Motorola charger. Now let us see the no load voltage. I am using a USB-C to normal USB-A adapter. Let us see the no load voltage. The no load voltage is 5.48 volts. Now let us plug in the load. I have to keep the load properly isolated from the system because this can go up to 120 degrees. Now load it up. Now look at the current. 2.51 amps. Now look at the results. 2.5 amps at 5.4 volts. The voltage has barely dropped. And let us see the ripple, the most important metric to judge the power quality of a charger. The peak to peak ripple is 52 millivolts at about 2 megahertz. Our next contestant, the 68 watt PD charger from Motorola. We are using the same USB-C to USB-A converter. The no load voltage is 5.4 volts. Now let's load up the device. The full load voltage is 5.42 volts. It's consuming current of 2.49 amps. Let us see the power quality. The peak to peak ripple is 100 millivolts and the switching frequency is 68 kilohertz. Our next contestant, the 33 watt Motorola charger. This one has a direct USB port. The no load voltage is 5.545 volts. Let's load up the charger. The voltage has now increased. The controller has increased the voltage to 5.57 volts at 2.57 amps. Look at the power quality. This one has a switching frequency of about 50 kilohertz and the peak to peak ripple is about 85 millivolts. Our next contestant, the Samsung 15 watt charger. This should be interesting. First, the no load voltage 5.4548 volts. Under full load 5.49 volts, 2.54 amps. Now let's look at the power quality. This one has a switching frequency of about 90 kilohertz and a peak to peak ripple of 161 millivolts. Our next contestant, the original Asus charger. Voltage is 5.48 volts. What about full load? .14 volts at 2.34 amps. What about the power quality? The switching frequency is 50 kilohertz and the peak to peak ripple is 75 millivolts. This one is the cleanest. And now comes the aftermarket off-brand chargers. This is the U-Bond 500 rupees 25 watt charger. This is the no load voltage 5.5 volts and after loading it up fully 5.45 volts at 2.5 amps. We can say the switching frequency is about 150 kilohertz and look at the peak to peak ripple voltage, it's 330 millivolts. That's quite something. Now comes this off-brand level aftermarket USB charger with 3 ports. What's the no load voltage? Let's plug it into just a random port. 5.45 volts. After loading it up It's 5.36 volts, 2.45 amps. What about the power quality? Well, goodness me, the peak to peak ripple is 1.3 volts. Goodness me. Oh my goodness. You can see it in your own eyes. It's frequently shooting above 1.4 volts. Now the second cheapest charger. This is a rupees 300 charger with an inbuilt display. The no load voltage is 5.5 volts, although the display says 5.2 volts. But after loading it up, it is 5.36 volts at 2.4 amps, but the display says 3.7 amps. I wouldn't rather trust the display so much. The peak to peak voltage is 150 millivolts at about 60 kilohertz. This one gained my trust. This one is actually the cleanest of the off-brand chargers. It is the final contestant of the series. The 150 rupees charger. Tell me, what do you think this will do? Pause the video and tell me in the comments. Okay, the no load voltage is 5.5 volts, and after loading it up, 5.43 volts at 2.5 amps. The switching frequency is 55 kilohertz, and the peak to peak ripple is 352 millivolts, 350 millivolts. So that's it for today. In my next video, we will be testing power banks and power bank modules for the quality. In my next video, I will be testing power banks and power bank modules with the similar parameters. So subscribe and stay tuned.